wonderful learning individuals. It is a pleasure. How are you all doing today? It is so great to have you. Thank you also so much for pressing the play button. I am Johnny, your host with HomeCountry Mathematics. Please feel free to stay to also learn, because mathematics can really be fun. Now, let us learn some math, shall we? All right, guys and gals, it is great to have you. Thank you for being here. Thank you for learning along. Here to support all students and parents. Yes, I love it. It's great to have you. We are continuing, trying to finalize this section, Unit A, Section 1-1, Prerequisite Skills, Operations with Fractions, Adding and Subtracting. I've been trying to do my best to give you guys and gals plenty of examples. As promised, I'm going to continue on with some more of these fractions. This will be the last video on fractions for now, unless I do something else. But I would like to continue on to the next section. Again, it's great to have you. Thank you for learning along, and let's do this. 1 subtract 1/19. Okay, I gave you some examples of what to do here with a whole number. 1 is a whole number, correct? 2 is a whole number. 5 is a whole number. 7 is a whole number, correct? We can take any one of these whole numbers and easily turn it into its own improper fraction. It's that easy. Okay, so just looking at it like this, we can also write this like this. Whoops, my bad. We only need one of those. Okay. 1/1 subtract 1/19. To make this simple, we are just going to keep the 19 as our denominator. Because why use any other number, right? Makes the most sense. We are going to use 19 for our denominator. All right, it's all the same steps, guys and gals. We just ask ourselves, what times 19? Well, basically you get the idea. What times gives us 19, right? So essentially all we're doing, to keep this simple, we just multiply the denominator by 19 and the numerator by 19. It's that easy, okay? It's kind of like mathematics is like a balancing act, right? And essentially that's what we're doing. So nothing's changing here because the denominator is the same, right? So it's 19 times 1 here, 19 times 1 here, gives us 19/19 essentially. It all means the same, right? 19/19 also equals 1, right? Or we could write 1/1. It's all the same. All right, let's continue. So nothing's being done here on our right-hand side, left-hand side, right-hand side. No work. Let's continue. Our final answer is 18/19. Wasn't that easy? Yes, it was. All right. Perfect. And it makes sense logically, right? We could take the whole number 1, make it 19 over 19. You can see we're going 19 minus 1. That's where we get the 18 over 19. You can see how it all works. We're only taking 1 off the whole, right? The whole being 19. The whole meaning all of it, everything. Okay? All right. Just in case you didn't understand what I mean by whole, concept is like a pizza, right? You have a whole pizza. Now we have 2 halves of a pizza, right? Now we have 1, 2, 3, 4 quarters of a pizza, right? This is the whole, which is 1. 1 is a whole, right? Make sense? I hope so. All right, let's keep going. 9 over 10. I want to try to smash as many of these as possible for you. Subtract 3 over 5. We're just going through this quickly because I feel like I've given you guys a lot of good examples. So good luck. We're going to use 10. And therefore, I'm going to bring 9 over. Our subtraction. By now, you guys and gals should have a good idea what I'm doing, right? If you're following each video series. Again, it's great to have you. Thank you for watching and learning along. What times 5 gives us 10? That's 2. 3 times 2 is 6. 9 take away 6. It's going to be a positive number. And that is 3. And we're left with 3/10. And also, let's have a look here. 3 is a prime number. Therefore, we are done reducing. Hopefully I haven't made any silly mistakes. I don't have any answers for these guys and gals. Just doing it. All right, 31 is 3/4. Subtract 2/3. I'm going to go with 12. 3 times 3 is 9. Subtract. 4 times 2 is 8. 9 is positive. Our answer is going to be positive. The answer should be 1 over 12. All right. Let us continue. Okay, 4 over 15. This is for those of you that actually, because I screenshot these for you to try these out, and I'm doing this for you guys and gals, the ones that actually did the work. I so appreciate you. Okay, 15 times 2 is 30. 4 doesn't go into 30, so it looks like 45, no. 15 times 4, that's that's going to be double, so 60. Trying to think, does 4 go into 60 doing the long work? I could easily be lazy and use a calculator. But why would I do that when I have a brain? 1 times, that's 4. 2, perfect. 0, 5, perfect. There's our number. Common denominator is 60. Okay, continuing to work. $60. Four times 4 is 16. Plus 15 times 3, that's 30, 45. Long math here, I guess. Plus 11, carry the 1, 5, 6, 61. I get 61 over 60, which I could turn into 1 and 1 over 60. All right. If you've been following the series, you know the steps it takes to go from improper to mixed. Okay? All right, let's continue. I'll check all these answers later. Okay, 11 over 12. Trying to go through these quickly. If I had a pen, I wish I had a pen. Probably be a lot easier, right? 11 12s, oh, subtract 4 over 15. So we're starting to get these kind of denominators where, you know, trying to find a number in between. Let's do, I really don't want to go 15 times 12, but let's just see what the number is going to be. That's 10. Carry the 1, 2, 3, 0, 5, and 1. So I get 180. Okay, 12, let's see. We need something, I would like something smaller. I really don't want to use 180 for a common denominator, but we may have to. Let's look at our 12s row here. Quickly, do any numbers go nicely with 15? 15 doesn't look like it. I doubt 120 does. 15, 30. Hold up. Hold up. Hold up. Hold up. Oh. That's 12s, 120, but 15 can go into, does 15 go into 120? Sometimes you gotta do a little extra work to find that number. So I have to actually go, because now I'm using actually 3 ones, tens, hundreds place. So if I go 2, I know that's 30. If I go 4, I know that's 60. Okay, this might work. So if I go 8, I'm just doubling, right? Is 120. So 15 times 8 should be 120. 8 times 5 is 40. Carry the 4. 8, yes, 120. We're going to go with 120. I think that's going to be our common denominator. Okay. And then if I have to reduce from there, I will. All right, 120. What times 12? That's 10. So that's 110. Subtract. We determine that 15 times 8 equals 120. Therefore, 8 times 4 is 32. Subtracting 32. Subtract. I gotta borrow. Make this a 10, which makes this 10. That's 8. 10 take away 3 is 7. So I get, whoops, 78 over 120. I just have to ignore it. Over 120, which I know I could reduce. I probably could have figured out, yeah, I probably could have went 60, right? Yeah, I could have went 60. So let's just divide these by 2. I know that half of 70 is 35, plus half of 8 is 4. So plus 4 is 39. 39 over half of 120, right? Half of 12 is 6, right? So 60. I just divided everything by 2. I have a 39. Now that's my next question. Prime numbers. Is 39 a prime number? No. Goes from 37 to 41. Okay, but I don't think it could reduce anymore. 3, well, 3 goes into that. Yeah, I can reduce more. 3 goes into 39. No, 3 times 10. Yeah. So that should be, hold up. Let's do the long work. A little more work with these bigger numbers, right? So 3, that's 1. Bring down the 9, that's 13, right? 13 times 3. Yeah, we can go a little further. 13. Because 3 divides between both, right? So half of 6 is 2. It's 20. There we go. I could have went, so now you see, right? If you end up not figuring out the lowest common denominator, you're going to end up having to reduce, and that's fine. I just quickly did everything by halves. 13 is a prime number, and we are done. 13 divided by 20. Hopefully I didn't make any mistakes anywhere, and we're golden. Alright, how are we doing for time? Yeah, we're at that mark. Let's see. We did 11, 12, so there's only 3 left that I didn't get done. Or completed. Trying to get through all of them, but trying to also keep it short. Let's do one more quickly. 3 over 11 plus 1/8. Okay, this is what I mean by those weird denominators, right? I could quickly go 88, right? Is there something smaller? 11, I don't think so. So we might have to do a little reducing, okay? I'm just gonna multiply and use 88. And then if we have to reduce, that's fine. Wowzers. All right. 8 times 3 is 24. Plus 11 times 1 is 11, which equals 5 plus, so 35 over 88. All right, so 7 doesn't go into that, neither does 5, and also prime numbers, 35 is not a prime number. So can we reduce anymore? I don't think so, because we know that 5 times 7 equals 35, right? I did the math right. 4 plus 1 is 5. 2 plus 1 is 3. And so 5 doesn't go into 88 nicely. Like, you could divide it, yes, but you'll end up with a decimal. We want a whole number return, right? That's what we want. Okay. I'm going to leave it at that. 35 over 88. Hopefully that's the answer. There's ways to check these just quickly using a calculator. I meant to find out what my son's calculator is. I purchased it for him, and it actually has a setting. You could go into the settings, and it'll actually return to you fraction form versus decimal form, which is kind of nice. I used to be able to know how to do that mathematically, the long work, but things you kind of forget over the years. All right, that is it. I'm going to leave it at that. Drop the A's. There was only a couple left, right? There was the 94 over 100. That looks like it's fairly easy. We know that 25 goes into 100. You could use 100 as a denominator, I guess. And with the other one, 25 and 6, I'd probably go, let's see, 25 times 6, 50, 150, it works out too. So trying to find another number in between, I don't know. You might end up having to use 150 and reduce. All right, great job to every one of you that actually, you know, put into work and put into time. Keep grinding on, because the more you do, the better you're going to get. In all honesty, that's the truth. That's facts. Okay, you get the foundation. You got to get the foundation down. And if you plan on like going, you know, obviously most of you are going to want to finish high school, right? But if you choose to go into college or whatever, obviously there's mathematics still, right? So when you start getting into the higher level or college mathematics, there's a lot of factoring and stuff going on. And fractions, you're going to be working with it a lot. So good luck, keep grinding, and keep doing your best. If you make mistakes, don't worry about it. Continue grinding. You'll get it. All right? Everyone that's watching supports you. We all support you. I'm Johnny. Remember, guys and gals, sharing is caring. Good luck in your studies, everyone, and thank you for watching, and we'll see you in the next section. All right.